So our first section of Trig is section 1.1. We won't be doing every section, so pay attention to your syllabus. Like we'll do 1.1, but we'll skip 1.2, and then we'll go to 1.3. So pay close attention to your syllabus, and you'll kind of know where we are. This is all about angles, and for the first part, I just want to review so that we make sure we're all comfortable and we all are using the same terminology. This is not something you're going to be tested on. I just want to make sure that when I say the initial side, you know what it is. When I say the vertex, you know what it is. Okay, so over here we've drawn an angle, and its vertex, you know, it consists of two rays, and the vertex is the point they share. See this arrow right in here, how it's drawn? And it's pointing that way? That means that the angle starts along this side. This is called the initial side, and this is called the terminal side. This is the direction of rotation right here. Are we okay with that? Okay. Normally in trig, if you're not told otherwise and you're going to draw an angle, you start the angle as if you're starting from the origin and towards the positive x-axis. So normally, that's where your initial side is going to be. So the vertex will be the origin, and then the initial side will be along the positive x-axis. If you rotate counterclockwise, which is this direction, to get to the terminal side, that is a positive angle. So counterclockwise is positive. It's very counterintuitive, I think, to what we want. I think, personally, if it were me, I would rather it start up and down because that's 12 noon, because that's north, and I would rather it move clockwise. I do not know why they didn't do that. Okay? The only nice thing about it is that it rotates through the quadrants in order. So a positive angle will rotate through quadrant 1, 2, 3, 4 in order. But it is counterclockwise. It's backwards from everything you think about on a clock. If you go the other way, if I started from here and I rotated this way, that would be a negative angle. Now they achieve the same result. They land in the same spot, but they have different angles of what we call rotation. Let's just say that I went 300 degrees this way. So we would call this a rotation or an angle that had a measure of 300 degrees. If these are the same, how much does this have to be? It has to be negative something. How much? Why would it have to be 60?
Because 360 is the degree of the circle.
Yeah, 360 degrees is the total degrees in a circle, right? So if they're the same and I go around one way and then the other, together those would need to make 360. So it's different though, because you know, when you're talking from an engineering standpoint, it matters which way you rotate to get there. It certainly matters which way that clock rotates, right? Yeah, I mean, we definitely don't want it to start running backwards. Well, actually, maybe I do. I don't know. So that just kind of gives you a start on positive angles, negative angles, and you can tell by looking at the direction of the arrow. Counterclockwise, positive, clockwise is negative. So just for a second, I want to do a quick talk on what degrees are. You've probably been talking about them since, what, 3rd grade? They kind of start you off with angles. I mean, really young now. But what is it? Does anybody know? What's a degree? Like what's a penny?
Cent.
1 cent. What's that mean? What is it?
A numerical value.
It's one what?
Part of 1%.
It's part of a whole dollar. How much? 1 out of 100. What's a nickel?
5
5 out of 100. Okay, so now you're kind of getting there, right? 5 out of a dollar. Okay. A degree is just defined as 1 out of 360. Every revolution, one complete circle or revolution, has 360 degrees. And a degree is just one of those tick marks. So if you take a circle and you divide it into 360 equal pieces, that's what a degree would be. Now we have a little more trouble with like visualizing 1 degree. But if you can think about this, if I take a circle, and I'll draw it on here just so we can see it, or I won't. There we go. And I go from here to just here. Like if I stop here, how many degrees have I gone?
90.
90. That's what's nice about 360 degrees, is that it's divisible by a lot of numbers. It's divisible by 30, it's divisible by 45, it's divisible by 90, and it's divisible by 60. And those are all geometrically important measures. Does anybody know where a degree came from? No? No. Connor, you know. Where'd it come from?
The Babylonians,
How long ago?
like 2,000 years ago.
I think it was around 4,000 years ago. It's a long time ago. The Babylonians came up with the idea, and nobody really knows why they chose 360. The conjecture is that they started to realize that it took about 360 days for like the seasons to go all the way around, and so they were starting to realize that's about how many days were in a year. That's what we, that's kind of what we think. And so then they, if they had known it was 365.25, that would really, really stink for us because it wouldn't be divisible by much of anything. So it's really nice that they chose 360, although we don't really know why they did. But it's just made up. There's nothing magical about it. They just decided we were going to call one revolution 360. So. And just to kind of run through it in review, if an angle is between 0 and 90, we call it an acute angle. If an angle is exactly 90 degrees, we call it a right angle. If it's between 90 degrees and 180 degrees, we call it obtuse. And if it's exactly 180 degrees, we call it a straight angle. Does anybody know what this symbol is right here?
Theta.
That's theta, yeah. It's just a Greek letter. We use it as a variable, and in trig we use it a lot to represent an angle in degrees, but it doesn't have to be theta. It could be anything. You could use x, you could use beta, you could use alpha. This book that we're using tends to use Greek symbols for degree measure, and it uses like our alphabet, like the English alphabet, when we get over into radian measure, which is kind of nice because you can kind of be reminded by looking at it, or do they want it in degrees or do they want it in something else? That's not 100% true all the time, so be careful to read the directions. But they do tend to use Greek letters for degree angles. Anything over 180 degrees technically isn't considered an angle, but in trig we call them an angle. They go, oh, what's the angle? And, oh, 740 degrees. It's technically a rotation, but so really degrees can measure rotation, or they can measure an actual angle in a triangle situation, or any kind of polygon actually. So, is that okay? Great. So before we actually get into anything new that you probably haven't done, like in geometry, let's just go back over a couple of geometric concepts that are really important to trig. The first is the idea of a complement and a supplement. If we say two angles are complements, that means that together they add to 90 degrees. Yeah. So complement means that it adds to 90. And a supplement means that together the angles add to 180 degrees. So if we take an angle of 40 degrees and I want to find its complement, what would that have to be?
50.
50 degrees. Because 90 minus 40 is equal to 50. So that's how you find complements. You just subtract the angle you know from 90, and whatever's remaining has to be the complement of that angle. To find a supplement, you simply take 180 degrees and subtract from it the angle you know. So the supplement to 40 is 140 degrees. Perfect. We use supplement more than complement, but once we get into solving right triangles, do you guys remember in a right triangle, one of the angles is 90? And what has to be true for the other two? They have to add to...
No, they have to add to 90.
They have to add to 90 as well. Why?
Because a triangle's inside angle is measured 180.
A triangle's inside angles always have to add up to 180. So if one of your angles is already 90, that means that the other two must be complements. They have to add to 90 as well. So that's something nice and useful that we'll use kind of later on down the road. But we use the 180 degrees a lot because there are a couple of identities that deal with that, the cofunction identities. And then finally, I want to caution you on something here. I'm going to pause and I want you to work this problem. It says, find the measure of each marked angle. So for this problem, we have an illustration here, a diagram, and we can see that together those two angles have to be what?
90.
And we can tell because it has the 90 degree mark there. So together they have to equal exactly 90 degrees. So we know that 6x plus 3x must equal 90. So 9x has to be 90, which means that x has to be 10. A lot of people just stop there, but you have to be really, really careful. Make sure you read the directions. This asks you to find the measure of each marked angle. So it didn't ask you to solve for x, it asked you to find the angles. So if x is 10, then this angle is 6 times 10, which is 60, and this angle is 3 times 10, which is 30. And together we can see that they equal 90.